In this video, we'll be talking about the structure of the sun. This picture here tells you a brief, the layers about the different layers of the sun. So the first one, the deep, this is the core. The second one is the radiative zone here. The third one, I'll just write down here, from inside out. If you look from inside, out, we have the different layers. First one is the core. This is the core here. The second one is the radiative zone. Which is this area here. The third one is the convection zone. Which is shown by this area. The fourth one is the photosphere. The photosphere is the surface of the sun. The fifth one is the chromosphere. The chromosphere is the closer atmosphere to the sun. And the second one is the corona, which is this area here. In this video, I will be explaining about core. If you look the core is only about the 25% size of the sun. The temperature inside the core is the temperature is about 15 million Kelvin. The core density is 160 gram per cubic centimeter. If you compare with the gold, then it is about 8.5 times more heavier than the gold. Inside the core, you mostly have the hydrogen and the helium. So if you look inside the core, 600 million tons of hydrogen burns into helium. $600 million tons of hydrogen burns into helium in 1 second or every second. And this amount of energy is equal to about 100 billion nuclear bombs. $100 billion nuclear bombs. So you see, I would like to repeat this word here. In every second, 600 million tons of hydrogen burns into helium, which is on the earth equivalent to 100 billion nuclear bombs. In 1 second, that much energy is produced by the sun. The power generated by the core this much power is generated by inside the core. So, again, if we could harness this, if we could capture the energy produced by the sun in 1 second, it could provide us the energy for 500,000 years. So it can fulfill our energy demand for another 500,000 years. That's how much energy is released by the sun. So now let me talk a little bit more about this one. So if you look inside the core, it is very heavily packed, and the way it is generate energy inside the core is by a process called the nuclear fusion. I'll just write it down here. Nuclear fusion. The fusion means the two atoms come together and becomes one atom. Nuclear fusion So if you calculate mathematically, the sun can still provide us energy for another 5 billion years. So the sun is providing the energy since last 10 billion years, and we are halfway. So it will continue to provide us the energy for another 5 billion years. Now, once the nuclear fusion happens, the photon generated inside the core will travel inside the radiative zone here. And the density is so high that it takes about 1,000,000 years for the generated energy or the photon to travel from the core to reach to the surface. Just to this distance, it takes almost about 1,000,000 years for the photon to travel. That means the energy, the sunlight that we are receiving right now at the Earth's surface was generated 1,000,000 years ago inside the sun or inside the core of the sun. And the reason is this area, the core and this radiative zone, is so densely packed that the electron the photon almost travels 1 inch per second. It is so extremely slow. So it takes about 1,000,000 years for the photon to travel from core to the surface. So that's it about the core.